Okay, well, welcome everyone to this meeting of the virtual CICS user group. I'm Trevor Eddles. I'm CEO of a company called iTech Limited. We're a mainframe consultancy, analysis and technical authoring organization. We're responsible for the content on the virtual CICS website, and we produce the newsletter. And that website can be found at itech-ed.com/virtual CICS. Okay, let's start by running through the agenda for today. And as usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Todd Havekost. He's Senior ZOS Performance Consultant at IntelliMagic, and he'll be discussing new ways to analyze CICS transaction and statistics data. And a copy of his slides from this presentation will be on our website later today. And if you missed any of our previous meetings, you can download copies of those presentations from our website, and you can listen again to the whole meetings. There's a link on the resources page of our user group website. And then following Todd's presentation and any questions you have for him, we'll move on to the latest CICS news, the latest CICS related articles. And then I'll give you the dates and times for the next virtual meetings. So that's the plan for this meeting. I'm anticipating that it will last for probably just over an hour. Okay, so as I just said, today's presentation is mainly from Todd Havekost, and Todd is a senior ZOS performance consultant for IntelliMagic. He's got over 40 years of IT experience with a primary focus on system and subsystem performance across the IBM Z platform. But also speaking, topping and tailing his presentation, we welcome Brent Phillips. He's Managing Director Americas at IntelliMagic. So can I just mention questions? If you can type your questions into the chat, please, rather than unmuting and speaking them. And I'll pick up the questions at the very end, and we'll see how many Todd's got time to answer. And the good news is, if he doesn't get around to answering your question, I will be sending him a complete list of all the questions and asking him to reply to those, and I'll send you all a copy of the answers. So that's basically our plan. So yes, welcome Todd and welcome Brent. Let me stop sharing my screen. You can share yours. And you can start. I'll just admit a few people while we're waiting.
Okay, very good. Thank you, Trevor. Thank you, everybody, for joining us today. We're very happy to be presenting to the virtual CICS user group. As Trevor said, my name is Brent Phillips. I've been with IntelliMagic since 2005, actually. So I have a lot of history here and seen a lot of things, and I'll be just making a couple of comments at the beginning and then wrapping up back as we get to the end and questions and so on. So we'll make a couple of comments there. So to kick us off, let me talk about getting more out of the 110 data. I think everybody on this call has kind of an intuitive sense that there is more value in the SMF 110 record than you're easily able to access. From our perspective, over the years, what we've seen is that it really does contain what you need in order to quickly understand and solve almost any problem that's going on. So from our perspective, if you have good access to the SMF data, the historical SMF data, and you can track it down in a post-mortem of what went wrong, you should be able to do it in a near real-time fashion as well. If you can be able to slice and dice and get some computer automation that helps you understand what's going on as the data is being created, as opposed to spending days or a week or whatever in the post-mortem. And really the same kind of thing is true for actually proactively avoiding many of these problems that occur Because if you can see some things that are starting to skew into an unsafe area for the infrastructure to be able to handle it, then you should be able to, if you can do that in a postmortem before you were aware of the problem, you should be able to do it proactively or predictively is the point. But why is it not commonly done? As you know, the volume and complexity of the data is really immense. We have one customer that we're working with now that sends about 130 gigabytes of 110 data to us every hour during their peak periods, and that's compressed 1 to 10. So just the volume of how many metrics are there, of course, it's cutting one for every CICS transaction. It's just not really suitable for human consumption to be able to go through it and figure it out. We need the computer to help us. So another issue, of course, is most sites on the SMF 110 historical data, it takes a while to get it. Many sites are still using more antiquated processes where they're looking at yesterday's data, and it's in a catalog of static reports, not really where you can just click to query the data live as your new questions come up based on what you're seeing, or to narrow the time frame or filter, or to click to be able to customize the kind of view that you're currently accessing. So that inhibits this process of quickly understanding or proactively avoiding many of the common problems. And as we know in our industry, many of the mainframe experts are retiring, especially those with good performance and capacity planning experience. The pool of deep experts is not as big as it was, certainly, while the mainframes tend to be getting bigger and more complex. So new people are coming onto the team, but it takes quite a while to learn what's really important and what matters to look at. So our perspective is there's a big difference between interpreting what the data means and the measurement data. In the performance and capacity planning area, for years the phrase has been, if you can't measure it, you can't manage it. Well, that's not the problem with CICS, right? There's plenty of measurement data. The problem is, what does it mean? How do you understand what it means? And there's also typically in most mainframe shops, a lot of silos of expertise and a lack of visibility between the different areas. And of course, they are interrelated on the system side, CPU side, coupling facility, data storage, network, MQ, so on and so forth, DB2, for example. I mean, obviously, there's interrelationships between those areas that are very important when problems start to happen. And so that's one of the issues that we've come across as well. But we've learned a number of things over the years working with this data. And so what I'm just pointing out here are some things to pay attention to when Todd is doing his coverage of what we would term the best practices. And that some of it might go a bit quick, but if you can access the recording of this session and rewind, it might be helpful for some of it. But the things that we've found can really, be a game changer for understanding this data more proactively and using it to more quickly solve problems is to really augment the human team with machine decisions. That will be a force multiplier for your team, because computers are so much better about checking things if they have the proper algorithms that understand, for example, all the things that are in the IBM Red books about, for this particular metric, what's good, what's bad, and can automatically highlight the statistically significant anomalies through some kind of automated change detection. So those are some of the things that we think are best practices. Of course, you have to have some software to do that. It's not necessarily a sales pitch only for our product, but obviously that's what Todd is going to use to show you the examples of what's in the data and what's valuable and why it's valuable. Getting more near real-time access to the SMF 110 data is very important, with a user interface that allows you to navigate and just click to do the live queries, so you can rapidly progress in your investigation of what's going on. And again, for the silo problem, a common user interface, so having one interface that can give access to the other areas as well, has been proven to be a very valuable capability for our customers anyway. So those are the three things I think we would like to highlight as you may be considering how to modernize the environment over the mainframe data. A lot of operation analytics solutions are being put in place for the distributed systems environments, and we've found more and more mainframe managers are open to that kind of modernization in the mainframe space as well. So with that, I'll turn it over to Todd, and he can show you what we're talking about.
All right, thank you, Brent. Trevor, I just realized I forgot to ask you, is there a way, are you seeing this thing that's blocking the bottom part of the screen? And if so, is there a way I can, oh, well, maybe that's my answer right there. Is that good? Okay.
We're all good. Well,
yeah, it's fine. It's great, Todd.
Okay, great. Thank you. Okay, so probably as this audience is probably quite familiar, CICS performance analysis focuses on two primary SMF records. The first is CICS statistics, 110 subtype 2, which reports on shared resources within CICS regions, and examples of several of the components of CICS that report statistics metrics are listed here as well. And then the second type is the transaction level data, and the 110 subtype 1. CICS produces a wealth of data here, approximately 400 discrete fields, of which approximately 100 are timing buckets. And as Brent mentioned, transaction volumes in many environments generate massive volumes of SMF data here that can be challenging to analyze. So that's one factor among many that drives the need to have modern ways or new ways of analyzing CICS SMF data. And so from my part of the agenda, we'll be talking about how can we leverage assessments of key statistics metrics, and then analyzing other metrics, analyzing CICS timing, transaction timing metrics, and other CICS transaction metrics, and then a little bit about enhancing CICS performance analysis through integration with other types of SMF data. So the CICS statistics data contains many metrics that lend themselves to being assessed to proactively manage the overall health of the CICS environment by identifying potential risks to availability and performance. And again, we've got so many regions and so many metrics that the need to automate these assessments is apparent. And again, as Brent mentioned, I'm going to be using IntelliMagic Vision today to illustrate some of these new ways of looking at data, because it's, I think, a lot easier to grasp the value that these new capabilities can provide when they're being demonstrated rather than just trying to describe them with images on slides. And also because interactively exploring actual CICS SMF data is more interesting and educational, and so that enables me to cover a good bit more content. So if you're not a current customer of IntelliMagic Vision, the session is still going to show you many capabilities then that you can seek to leverage to enhance your analysis of CICS SMF data using your product or products of choice. So the IntelliMagic Vision implementation of health assessment checks. It checks more than 70 metrics for every region, uses customizable thresholds that are initially set based on business industry best practices. So here are some examples of CICS statistic metrics that lend themselves to being assessed in managing the overall health of each region. All right, so now let's look at some examples of the potential value that health assessments can provide. So again, as I mentioned, in this implementation, user-defined CICS groups are being utilized to make assessments of hundreds of regions quickly consumable, and to direct attention to metrics that might, issues that might warrant some investigation. So here, this is a storage health, and so some of the metrics you'd expect, including time short on storage. So we come down to this group of regions, and we see that there's some exceptions, including short on storage. So here is a view of all those kind of time charts of all those metrics kind of at a glance. So for example, you can see when the times occurrences of short on storage is occurring, that coincides with some other get main related exceptions that are going on at the same time. All right, so here's a count for this group of all the regions in this group of the number of times that short on storage is being reached. And one of the first questions we may want to ask from that then is, okay, well, which storage areas am I encountering this condition? And in this particular case, there's 3 different extended areas: extended user DSA, extended read-only, and extended shared DSA, where the condition is occurring. So then looking at the extended user DSA across the regions shows that it's occurring on many, many different CICS regions within that group. One other question that commonly arises when you're exploring SMF data is whether the behavior that you're seeing is typical or reflects an anomaly. And so viewing the data over time is often of great interest. So here I'm going to look across, I've got a week's worth of data in this demo database, and look at the occurrences of short on storage by day. And we can see here that it is in this environment, it is happening pretty much on a daily basis. Okay, so that's a little bit on storage metrics. Another metric that lends itself to being assessed is the volume of storage violations that are being detected. So again, here in this case, we've got one instance of that. So we look into that by group, and not very often occurring, but anyway, there are a few occurrences. And again, if we want to look and see which transaction is that occurring in, it looks like it's a set of transactions that have the first same 2 characters in this particular environment. So that then could potentially be a first step in an action plan to addressing those. Another metric that lends itself to being assessed is related to CICS NQs used for serialization. So in this example here, for this group of regions, there's a lot of NQs being rejected due to NQ busy. And looking at the NQ pool names, you can see that they're all occurring for this one particular resource name. So again, here's a set of time charts for all the metrics. We can see here, if we look at the total requests, that there is a very high volume of these NQ requests going on for that group of regions in this environment. We look at the NQs that are being rejected due to busy. Here's the frequency of those. Again, if we look at it across regions, and here we can see that it's very consistent pattern across well, at least about a dozen or so of the regions in that group. We might also be interested in comparing the NQs being rejected to the total number of NQs. We saw a minute ago, there was a real high volume of those. So let's just put it together on the same chart, and then now we can see what the relationship is between the two. And we might look at that then and say, well, that's the application design to have that amount of NQs being rejected. So then that might be fine, or it might warrant some additional investigation. NQ behavior can also result in waits rather than being rejected. And so we look here, we can see that there's another group that has some amount of wait time. So again, we could look at that particular group, and again, see which NQ is being the case. And a couple of other metrics might be of interest here. And again, this is kind of talking about what metrics does the CICS statistics provide for us, so we can, what kinds of questions we can answer. One of interest would be the percent of requests that wait. So here, less than 2%. And again, for that group, it's all that one particular resource. And we might also be interested in looking at how much time do we spend waiting. And again, for that group, it's very, very minimal, less than 1/100th of a millisecond per tran. So likely no concerns, and very likely kind of the way that application again is working as designed. All right, and then so that's using CICS statistics metrics for health assessments. Look at one other example of a CICS statistics metric, and that is the T-class, times reaching the T-class limit. Transaction classes are means to manage the mix of transactions, right? To protect against some subset monopolizing a region. So again, it can be a way that the application is designed. So here we can see that the T-class limit is being reached frequently for this group of regions. And we look at that by T-class, we can see two different T-classes are being frequently encountered for this particular group of region. And then again, if we want to see how that's distributed across the regions, here it's pretty evenly distributed across all 6 regions in that group. Another question that we might want to ask ourselves if we're hitting the T-class limit is, well, what do we have the T-class limit set at? And so for that particular T-class, we can just display that, of course, on a secondary axis. And in this case, it is set to 5. Other things we might look at with respect to T-class, here we can see the kind of how the percentages break down. So again, let's look at that for that group of regions. And here were those 2 T-classes are being encountered. This was the WREV one, was the one that was being encountered most frequently, but actually the percentage of transactions that are being queued is actually higher for the one that begins here with GY. So if we maybe want to look at that across time, so let me just keep that one metric that's being accepted after queuing, turn it into a line chart, and we can see then for that one that actually happened less frequently, but it's a greater percentage, we can see that more than 1/3 of the transactions are being queued for that transaction class. Again, other types of metrics that are available in the CICS statistics, we might want to say, well, how deep are the transactions being queued? And so here, for example, for that GYEV group, there's several intervals there where more than 200 transactions, the queue exceeded that during multiple intervals. Another metric that can be derived from the statistics data is the average time queued, and for each of the T classes. So again, for that particular GYEV one, there's many intervals where the average queue time is several seconds. So if you're using the T-class mechanism to manage the mix of transactions in your regions, then the CICS statistics data can give you great visibility into how that is operating. So here's a kind of a collection of into a dashboard of the kind of some of the views we've looked at so far today, just kind of by recap. We looked at times short on storage and saw which CICS storage areas was encountering that. Looked at the occurrences of time short on storage across a time interval to see how it's distributed across the various days. The NQ busy here, it was evenly distributed across many of the regions in that group. Here was how did the requests rejected compared to the total requests, the percent of requests that waited, and what was the average wait time. adding the T-class in with the occurrences of T-class, and then looking at the percentages of transactions, what was the peak number queued up, and what was the average queue time. So those were some of the metrics we looked at from the CICS statistics data. Again, lots of helpful information about what's happening at the region level. All right, so now let's move over to the CICS transaction data, the 110 subtype 1. And as I mentioned, there's more than or around 400 discrete fields for each transaction. And of these, approximately 100 represent timing buckets. So let's kind of start there. Those timing buckets can be grouped into high-level categories to help facilitate analysis. At the highest level, the response time is equal to dispatch time plus suspend time. Dispatch time is the time the task is dispatched on a CICS TCB, the time that CICS at least thinks the task is executing. And then that can, of course, be broken down further into actual CPU time and then the waiting time when CICS has the task dispatched, but ZOS has taken the CPU away from it momentarily. The other top level component is suspend time, the time the task is not dispatched by CICS and thus waiting. And the majority of the 100 timing buckets are components of suspend time. They're grouped into these high level categories: wait for first dispatch, IO wait time, other wait time, and then whatever's left is uncaptured wait time. And the wait for first dispatch also includes just delays for max task and T-class limits. So most of the suspend time components are classified into either IO wait time, that's about 15 buckets, or other wait time, and that's about 30 buckets. And as we said, the suspend time that's not captured in a discrete bucket is classified as uncaptured. I want to just also mention here that there's several resource manager interface timing buckets, because significant portions of transaction elapsed times can occur in the interfaces with resource managers like DB2, IMS, MQ, and TCP. And so CICS captures those times in multiple RMIs, elapsed time and suspend time buckets. But since the RMI suspend time buckets can be incremented at the same time as other suspend time fields, they're not included as components in the overall suspend time formula shown above. All right, so now let's explore some response time concepts, again using actual data. We'll start here from this view of top transactions by transaction volume. So we'll take this highest volume transaction. So to wrap our arms around 100 timing buckets, it helps to start from high level views that are grouped into those summary categories we just described. And so this particular transaction has measurable time, elapsed time spent in IO wait time, and also in CPU time. So those are the two categories of interest for this, high-level categories of interest for this particular transaction that we would want to look into more detail on. So for the IO wait time, for this transaction, it boils down to wait for control at the end of MRO and RLS file IO are the two components of interest of the IO wait time. For the CPU time, the QRTCB and RLS SRB are the two types of CPU time that are occurring. So in this example here, even though there's about 100 timing buckets for this particular transaction, there are really only 4 timing buckets that are relevant for analysis of that particular transaction. All right, let's take another view of transactions, this time by total CPU consumption. And again, we'll select one of those and look at the response times at the higher level here. And here we can see there's more variability over the time period, the selected day for this transaction. So, a question that might occur to us is, is there a correlation with the transaction volume? Is that what's driving the changes in the response time? So we bring that on to the secondary axis. We can see, well, there really doesn't appear to be much of a correlation here in this particular example. But again, the ability to kind of bring the variables together that you want to see based on the current view is another way that is an aid for CICS analysis. All right, looking across these thumbnails across the top here, another way we might want to explore the timing metrics is to work from those high-level categories. So in this example, this is the CPU time, and in the legend, we see all the different kinds of buckets that CICS uses to track that. So we look at that over time for a particular transaction. And again, for this particular one's QRTCB and L8 TCB, which is a pretty common distribution of CPU for transactions. Now, in high transaction volume environments, you want to keep an eye out on significant changes in CPU per tran, because that can have pretty significant CPU impacts, of course, across the whole processor. So, for example, before and after a application release, that's often an area of interest. So then would it be good to compare those? Now, in this particular example, I only have a week's worth of data in my database, so I'm not going to be able to compare across a weekend. But anyway, so I just compare with the previous day, and I see there's not a material change in the CPU per tran going on here. We're going to come back in a minute and look at some other high-level response time categories using views by region and by groups of regions. Another way that of potential interest to view the transaction data is at the response time by a view that starts out by total response time and does further analysis from there. I've kind of customized here a view in advance here of the top 4 transactions by volume, and just have their response times here on this particular view. So if I'm investigating this one in green here, one way I might be interested in viewing the data is by system, by the various ZOS systems where that transaction is executing. And when I do that, I see that I've got distinct profiles between 2 sets of 3 systems each. So let me take one of the higher response time systems and look at the response time distribution. And again, the primary contributor to that elapsed time is total IO wait time, about 26 milliseconds per tran worth. And if we look at the detailed components, it's all wait for control at the end of MRO. All right, let me take one of the lower response time systems and do the same, look at the same thing. So again, IO wait time is the biggest contributor, but now it's more in the 12, 13 millisecond per tran range, about half of what we saw earlier for the other system. And again, if we look at IO wait detail, it's wait for control at the end of MRO. So it appears we have very different profiles for this MRO metric across this 2 sets of regions. So I could go ahead and customize this and just pick wait for control at the end of MRO and view that by system. And it would take me a few clicks, but just to save time here today, I've gone ahead and done that in advance and just had it collected over there. So when I look just at wait for control at the end of MRO, you can see that that is what's really driving the difference between the 2 sets of systems response times that we were seeing here, approximately a 10 millisecond per tran difference. So, and as you may have guessed, in this environment, these 2 sets of regions reside on distinct processors, and the regions residing on the one CPC have longer inter-region communication times than the others. But so that's an example of the kinds of insights we can gain from analyzing the CICS transaction data. All right, so again, just to kind of recap a little bit of what we looked at here, views of response times by the high level categories, and then drill into the specific components of those that are pertinent for a particular transaction. So for that particular transaction, really 4 out of the about 100 timing buckets are particularly relevant. Here we brought in the tran rate to see if that was a correlation, decided there wasn't. CPU per tran across the various transactions and a by time view, and then this analysis where the response times differed materially between different sets of systems, and we isolated that down to the particular component that was driving that. So in addition to transaction-based views, we might also benefit from views that are begin by region or by groups of regions. So let's look at some views here that are by region here. This is the high-level suspend time categories for the top 20 regions here by transaction volume. So in this case, a region naming convention helps group regions with like workloads together. If we didn't have that, we could use filters or other mechanisms to select the regions that we wanted to view. But so in this particular case, for this first set of 4 and then the second set of 4 regions, almost all the suspend time is accounted for by IO wait time. And if we go over and look at the IO wait time for those regions, we can see it's almost all wait for control at the end of MRO. All right, and then back to the overall suspend time view, the other regions after those first 8, in addition to IO wait time, had components of other wait time and wait for redispatch that were measurable for those particular regions. Okay, so those are some views by region. Another way to look at the data is by groups of regions, user-defined groups of regions, commonly business application-oriented grouping. So here, we're looking at the resource manager interface time for these groups of regions, and we see many have components for DB2, interfacing with DB2, and also with IMS database control. This particular group also has a significant component of MQ interface time. If we look at that by region, we see that it is primarily this set of regions here, all of which have MQ in the region name. So let me just update this report and only select regions that do not have MQ in the name. When I take those regions out, then of course the scale expands for everybody else, and then we're seeing a pattern similar to what we saw with the other regions, where most of the resource manager time is in DB2 or IMS DB control. All right, one other high-level category, and that's wait factors relating to dispatch or redispatch time. And that shows one group that has high times waiting for first dispatch due to T-class limits. And you might recall we saw that group frequently hitting T-class limits when we reviewed the statistics data earlier. Again, when we look at that by region, we see that it's those same set of MQ regions that we just saw earlier with the MQ interface time that also has the long T-class delay times. All right, so again, looking at a dashboard that kind of collects some of those views that we just looked at. We looked at suspend time by region and also then the IO wait time components across different regions, and saw how the profiles differed by business application. Resource manager interface time, there was a lot of MQ time when we took the MQ regions out. was mainly then DB2 and IMS database control. And we then saw the T-class limit time showing up here for that particular group and how that was distributed across a set of regions. All right, so in addition to the timing buckets, the CICS transaction data also captures around 300 other metrics, and they're organized by IBM into subgroups as listed here. So again, lots of ground to cover. So we're going to just briefly explore the groups that are listed in the first column here. All right, so first we'll go look at web services activity. The CICS 110 subtype 1 transaction data captures information about both operation and resource definition names. So here we see the top CPU consuming transactions in this environment that are using web services. And so we can view that data by operation name. And let's go ahead here and view it over time. So we'll have just the CPU variable, which is what pretty much all that was anyway. And let's kind of take away a little bit of the noise and go with the top 10. And then I'm going to remove the ones that don't have a web service. All right, so now that gives us kind of a time view of the top CPU web service operation names that are being called by that particular transaction that we started from. Also, we could go the opposite direction and we could start with the web service names that are most frequently referenced. So again, I'll remove the NA out of there. And again, let's look at it over time. All right, so these are the resource definitions most commonly accessed. And then for any particular one of those, if we view it, for example, by transaction, we can see that that service is resource definition being called by this single transaction. And if we view that over time, we can see the number of requests per transaction is consistent, and then just the overall transaction rate of that transaction. So having access to the web service operation and resource definition names in the transaction data can help facilitate collaboration between the infrastructure and the application teams. Okay, so now over here on the left, we see those groupings of other transaction metrics based on the IBM groupings. So just again, selecting a few, for example, in the data requests, this captures metrics pertaining to the other resource managers. So this is the rate of SQL and IFI requests issued by transaction. And if we look at that top transaction by region, we can see that it's very common, around 250 SQL or IFI requests per tran that are occurring there. Other metrics in this group, the number of IMS database control requests, the number of MQ requests that are issued by TRAN, and then also wait times for IMS, and also wait times for DB2 threads or connections to become available. All right, CICS is a primary exploiter of the ZOS system logging functionality. So the transaction data captures the volume of log stream writes. And let me go ahead and select that particular transaction. And then there's a timing metric that is the wait for journal IO. So let's just put those both together and see what kind of, if we observe a correlation, and indeed we do. When there's more writes, there tends to be more wait for journal IO timing, as we would likely expect. All right, another group of metrics is the number of program loads per tran. So links or transfer controls or load, again, by transaction. Another group of metrics is temp storage. Puts to auxiliary temp storage, puts to main temp storage, and gets from and puts to shared temporary storage. Some of the, again, just kind of awareness here of the types of metrics that are available in the transaction data. Also, if for transactions that do their own IO rather than relying on DB2 to do it, you've got metrics around the file control calls at an aggregate level here, and then broken down by gets and puts and so on. There's metrics on virtual storage usage, again, available at the transaction level for many of the distinct CICS storage areas. So using extended user DSA as an example, here's the number of get mains per tran and the amount of storage occupancy and the maximum storage allocated in that particular storage area. So again, here's just kind of a recap of some of the things we viewed at in terms of the other types of metrics. You've got web service metrics by operation and resource names. You've got data with the interfaces to the resource managers, DB2 and IMS examples there. Log stream writes, and we saw the correlation with the wait for journal IO, program load data, temporary storage data, file control, and storage usage. So again, examples of the types of metrics that are available in the statistics data. Excuse me, the transaction data. All right, another aspect of new ways to analyze CICS SMF data takes place when teams can view types of SMF data across the ZOS platform, leveraging common intuitive tooling, and that enables a level of collaboration that's not possible with much of today's tooling that's siloed by area. Though CICS teams might wish otherwise, CICS does not exist on an island, but instead it operates within the ZOS ecosystem and interacts heavily with other subsystems. And so that means insights that come from several other types of SMF records can play important roles in assessing and maintaining the health and performance of CICS. So examples of that are insights into CPU utilization and efficiency from the 70 records, workload manager data at the service and report class levels on CPU consumption, and workload manager data relative to how service class goals are being achieved. And then for work originating from CICS, both DB2 and MQ accounting data capture the CICS transaction IDs, and that enables extensive reporting at the CICS transaction level. So again, having common intuitive tooling benefits all teams in all directions. The CICS teams who need visibility into how they might be impacted by what else is going on in the ZOS, broader ZOS environment, as well as other teams that are wanting to understand what's going on within CICS. So now let's look at an example of how CICS analysis can be enhanced when the CICS and WLM teams collaborate across their types of SMF data. So let's start from workload manager service class data from the 72s, and that provides the workload manager performance indices, which reflects the degree to which a service class is meeting a goal. And I'm going to do this analysis for a particular set of systems that have a common system naming convention. All right, so here we go. All right, so let's look at the CICS service classes, and initially we view them, the types of goals. So you've got, in this environment, you've got some velocity goals, which are commonly used for production CICS regions. are assigned to that execution velocity goals. And then production transactions often are placed in service classes with percentile goals. So we see both types here. So if we look at the velocity type goals here, there's a single service class, and we can see that it has a velocity goal of 72, and most of the time the achieved velocity exceeds that, and thus the performance index is below 1, which indicates that the goal is being exceeded, except for a few mid-morning intervals here. Also, that workload manager captures using and delay samples to calculate velocities, right? And so the ones that are of most frequent interest for velocity service class goals are using CPU and delay CPU. All right, now looking at the service classes with percentile goals. There's 2 in this environment, but this one in blue is the one that is most commonly used. So I'm going to just isolate that here, and we can see that for most of the day, the performance service class goal is far exceeded. But there are some intervals in the early evening here around 7 o'clock where it's missing, this service class is missing its goal. All right, so jumping over to a percentile view, look at, again, the CICS workload and look at that service class that we were viewing there. So here we see that the goal is 90% of the transactions less than 325 milliseconds. And again, for much of the day, more than 90% of the transactions are finishing in less than half of the goal, 162 milliseconds. But for a few intervals around 7 o'clock, the goal is not being met. 90% of the transactions are not completing within the goal. Now, that's about as far as you can get from the system's RMF data. So now let's jump over into the CICS data. Look at the CICS side of the picture. Okay, let's look at a response time view, and going to add the filter here to have the, I want to filter the transactions that have a response time that is greater than or equal to the goal, which was 325 milliseconds. So for this view of top 20 transactions by volume, we see there are 3 transactions that pretty frequently run longer than 325 milliseconds, the 3 that we've just highlighted there. Now, if I jump back over to just overall transaction volumes, and let's look at a time view, and I've still got that filter in place here. I can see it up here at the top. I've got that 325 millisecond filter here. And now I notice a spike in a transaction that was one of those that we identified earlier that averages a response time greater than the goal of 325 milliseconds. And we see a spike here right around the time when the WLM goal is being missed. All right, so now I'm going to take that response time filter off. So now again, we've got all the CICS transaction volumes, and I'm going to zero in on the time interval right around when we're at 7 p.m. where we're missing the goal. So I'm going to include the interval before, and I'm going to include the interval after. So that is three time intervals. So now that's just those 3 time intervals and the volumes that are occurring. And I'm really particularly interested in the distribution. And so the best way to view distribution data is as a pie chart. So now when I view the data for those three intervals, here's that DWWS that commonly runs longer than 325 milliseconds. And we see here now that it makes up almost 10% of the mix, transaction mix, during those three intervals. So exploring the CICS transaction data enables us to identify that the cause of missing that goal is due to a spike in transaction volume of a transaction that consistently runs longer than the goal, right? It's tough to make a 90% goal when the volume of a transaction that consistently runs longer than the goal represents almost 10% of your volume. So that's an example where having a common interface across data types enhances analysis. It helps the WLM and CICS teams collaborate to quickly and easily identify the cause of missing that WLM goal. All right, so today we talked about a number of new or advanced capabilities that enhance performance analysis of CICS SMF data. One is seeking to get out of react mode and to be automatically assessing metrics to identify potential risks to availability and performance. We just walked through an example where CICS analysis is enhanced when you have a common intuitive integrated interface, so the different teams can all see the different types of SMF data and collaborate together. A third new way is the capability to dynamically interact with and navigate through your data based on findings from the current view, and we saw examples of that today. When you combine that with dynamic navigation and context-sensitive drill downs, that enables you to quickly focus the analysis on the desired subset of data. Even though you've got a massive amount of transaction data, you can very quickly drill in on these areas of interest. And then finally, the capability to create dashboards that collect and preserve live shared views of metrics are very helpful to have help teams collaborate together and have a common view of what's going on. And we saw that as we recapped each section. So those are some of the capabilities that reflect new ways to enhance the analysis of CICS SMF data. All right, Brent, I'm going to hand it over to you.
Okay, thank you very much, Todd. Thank you, everybody, for sticking with us through that. It's a lot of information, I know, but we will have a recording available so you can backtrack, and hopefully it gave you a good feel for the kinds of capabilities, the kinds of things you should be able to do to solve problems more quickly and to even be more predictive and proactive in understanding what's starting to go wrong. We are going to share some more resources with you here in 2 slides down, and then we'll have time for questions. So if you do have questions for Todd, this is your chance. Go ahead and submit a question. We won't spend a lot of time on it, but we will get back to you by email if we don't answer them live here, as Trevor said. I just wanted to share this slide first before we do that. To let you know, I know I did recognize some names on the session today as customers, but some of you, many of you are not IntelliMagic customers. Hopefully you have something that gives you similar capabilities, because obviously it's very important to solve those problems quickly and mine the data for all that it's worth. What Todd was showing you is actually running in what we call the IntelliMagic cloud, where we believe that the experts at your site should spend their time on analysis and not, manhandling the data and the product infrastructure. I mean, that takes a lot of work. So we are doing this for some of the largest financial services companies in the world, for example. So we've solved the security problems about sending us this SMF 110 data and the other types that we get, of course, as well, in a continuous fashion. So it's always available to you in a web browser. The other thing that might be of interest to you about this setup is it makes it extremely fast to be able to test the capabilities. If you do have interest in seeing what your data looks like in IntelliMagic Vision, this process makes it quick and easy to be able to do that. So let us know if you have any interest in that, or have some specific service needs or consulting. We also use it on that basis as well. So the next slide, Todd, why don't we go ahead and share these resources? There's a QR code here. Again, you can get this either from the recording or from the slide deck that will be available on the user group website. So scan that in, and then you have short videos about each of these sections that might provide some inspiration for you about however you want to get that kind of value out of the data. And I think with that, there's another webinar coming up about mainframe cost savings. So you or some other people on your team might want to participate in. Again, that's available to register via the IntelliMagic website, IntelliMagic.com. And I think with that, do we have questions to answer, Trevor?
At the moment, we don't have any typed in, but if anyone does have any questions and they want to type them in quickly, we'll get Todd to answer them. We'll just pause for a minute or two, see whether people's fingers are rushing across the keyboard. If not, and I notice that we're just over the hour, and I know Todd's got to dash off. If you do type it in, I will send these questions off to Todd. When I get the replies, I'll send them back out to everybody. But at the moment, as you can see, we've just got a thank you from Jose Romero saying thank you, Brent and Todd. So
Okay, thank you.
perhaps
That's
we'll
good
leave it
enough
at
for
that
us.
and move on. Yeah. Thank you very much. Thanks, Todd. Thanks, Brent. And as usual, because we're a virtual user group, please assume that we're giving you a virtual round of applause. So thank you very much. Okay, let me go back to sharing my screen and we'll just run through a couple of slides before we finish. There. It moves all the time. Just quickly, I haven't got any news, haven't got any CICS news, so we'll go on to the one article that I found recently that was back in November, lifting the lid on CICS file control by Andy Wright, Felicity Merrison and Di Middleton, and that's in Enterprise Tech Journal issue 5. You can find that online, of course. So coming soon, well, 7th of March is our next meeting. And we've got Larry Strickland, who's Chief Product Officer at Data Kinetics Limited. He's going to be talking about attention. Well, the title of his presentation is Attention Application Developers. In-memory performance is key to the modernization efforts. And after that, we've got a meeting on the 9th of May, where we've got Colin Pierce back again to present. He hasn't given me his title yet, but I'm sure there'll be lots of demos in that, which will be interesting and useful. So those are the dates for your diary, 7th of March and 9th of May. Just wanted to tell you about our new virtual user group, the virtual DB2 user group. So if you've got DB2 people at your site who don't come to the virtual CICS user group meeting, then we've got a new one for DB2 users, and that's actually meeting next week on the 17th. If you want to join, then the link is itech-ed.com/virtual DB2. Just to remind you that we're all over social media. So you can find us on CICS and Twitter and Instagram. LinkedIn. And we're on YouTube. So the recordings of all these sessions are on YouTube. The actual links, I know they're on screen, but they're actually on the homepage of our website. So you can click on those and move forward with those. Okay, that's all for this meeting. Oh, hang on, I saw someone put something in the chat. Let me just stop my share for a moment to pick that up. All right, we've got a question for IntelliMagic. I'll send that on to you. That's probably the best way of doing that. So that's all for our meeting of this meeting, the virtual CICS user group. Let me thank you all for attending. Thanks to IntelliMagic, Broadcom and Data Kinetics for sponsoring our user group. And I'd particularly like to thank Todd Havekost and Brent Phillips for their presentations today. So that's it. Thank you all very much for joining the meeting, and I look forward to seeing you all on the 7th of March. So thank you all and goodbye.
Thank you. Bye-bye.
Thank you.